Hi dear students. So after a long gap, today we are going to start the second unit, that is digital transmission. So because of some problems, from many days I have not able to prepare the videos and I am not able to send you those videos. So today onwards we can start the second unit, all concepts continuously without any interruption. So before moving to the first concept of second unit, I want to tell you one thing, that is among all DC units, means for your syllabus there are total 5 units. So among all those 5 units, second unit is little bit confusing. Okay. Each concept you have to understand very clearly here, and if you have any doubts then you can ask me anytime. Okay, but please try to understand each concept clearly, because many concepts are very confusing here. So let us start the second unit, that is digital transmission. So in this unit what we study actually is how data is converted into digital form, means how data is digitized, that we study. So for example, if I write something on book, means like good morning students, then that is not a digital data. If we want to create it as a digital data, then either we have to store it in a computer or we have to convert it into text file. Then it becomes digital data. Agree or no? Okay, so now start with the very first concept of second unit, that is digital representation of information. So in digital representation of information, what we study is how the information is represented digitally. So to represent the information, we use two information categories here, that are block oriented information and stream oriented information. In digital transmission, the main objective, means the main goal is to transmit a given symbol that is selected from some finite set of possibilities. For example, in binary, digital information can be categorized into two broad categories. So in binary form, we divide the digital information into broad categories that are nothing but block oriented information and stream oriented information. So let us study one by one here. So first one is block oriented information. So what is meant by block oriented information then? This block oriented information includes data files and black and white documents and pictures that can be represented as digital information. So which information we can consider block oriented information? The simple data files, that is consisting of some text or some numbers, and black and white documents. So you can consider black and white images, black and white photos, and some normal pictures, means not colorful or clear pictures, some normal drawing pictures. So those can be considered as block oriented information. The most common example of block oriented information are the files that contain text, graphical information and numerical information. So this is what I have already told you. The normal files that contain text means ABCD like that, graphical information, some simple drawings, and numerical information means some numbers. So such files we consider as block oriented files. So we deal with these type of informations, means block oriented information, that can be used to send email and retrieve documents. So to send email and retrieve documents, we use such block oriented information. Then come to next one, that is stream oriented information. So block oriented information means already you know, that is it may contain text, numbers or some graphical images. Stream oriented information means the information such as voice, music or video that is produced in a steady stream. So steady stream means what? That is produced continuously. So stream oriented information means For example, my voice. So whatever I am telling now, that is continuously transferring, that is continuously producing. So this type of information we consider as stream oriented. So stream oriented information examples are voice, music or any video files. In case of voice or music, in case of voice or music or signals of sound which consists of variations in air pressure is converted into voltage, then that varies continuously with time. So for example, block oriented information, what we do is we directly get that information in digital form only. But stream oriented information is not like that. For example, voice. So whatever you are talking continuously, that is your voice going on continuously. So that is stream oriented information. So your voice varies with respect of air. So what I am talking now, it is clear now because here no air disturbance is there. If I say the same words in very high air pressure, then you may not get my voice clearly. My voice may not be audible clearly. That is because of variation in my voice signal because of air pressure. Are you getting? So this what happen is the voice or music means the stream oriented information will continuously vary. Vary means continuously change according to the air pressure. Means it will affect the air pressure. So such information means stream oriented information will be converted as a voltage signal first, not directly as a digital. It is converted as a voltage signal. That voltage signal represents variation in voice because of air pressure continuously with respect of time. And then that voltage is converted into digital signal by using some different techniques such as quantizing and digitizing. So using these two techniques we represent the variation of voltage in digital form. So that is not in more deep depth for your syllabus. So only the basic concept is there. So just try to understand. Once again I will repeat what is stream oriented. So stream oriented information means voice or music or video we can consider, means the information such as that produces continuously. Information that produces continuously. So that is stream oriented. So when information is producing continuously, voice is producing continuously, it will be affected by air pressure. Okay. So that variation, when it affects by air pressure, definitely there will be variation in information or variation in voice. So that variation we represent as a voltage first. Are you getting my point? Then that voltage is converted into digital using quantizing and digitizing techniques. Quantizing means what it will do is it will divide the variation in voltage at every per minute or per second. So whenever the signal varies, it will divide the signal there, means it will break the signal there. And whenever signal goes continuously, means whenever there is no variation in signal, then no quantizing. Quantizing means no breaking. Okay, so that particular part is considered as one digital information. Then again, when signal varies, at that point break the signal and convert it into digital. Like that means that each break of signal means each part of signal that represents variation in each voltage, that is then converted into digital. So this is called as digitizing. Quantizing and digitizing. Quantizing means breaking the signal when it varies, means making the part of signal to represent the variation in voltage. Digitizing is converting those quantized signals or voltages in digital form. So using these two techniques we can convert stream oriented information into digital form. Then here for example, my voice varies continuously. Sometimes you listen to me with louder voice and sometimes with less volume, right? So this is what such information values we represent as analog signals. So such voice signal we represent as analog signal. In next concept you will clearly study about what is analog and what is digital. Okay, just now you remember these stream oriented informations are represented as analog signals because they vary continuously, they change continuously. Then next one is compression. So compression means what? Before moving to compression, let us consider one example. Okay, I want to send a file to my friend which is of 30 MB size, which is of 30 MB size, and only the way I can use is I can mail the file to my friend. So using any mail facility, maybe Gmail, we can send maximum size limit is 25 MB. More than 25 MB file we cannot send using Gmail, right? So, but I want to send the file which is of size 30. Now what to do? What to do now? 30 MB file I cannot send using Gmail. I can send maximum 25 MB. In that case, what we have to do is we have to compress our file, right? So I think you have understood what is meant by compression. So compression means reducing the size of file. Reducing the size of file. So if this one, when we reduce the size of file, the data is compressed there. So this is called as data compression. Okay, but remember, when we compress our file, data is not lost. Understood? So my 30 MB file is, if it is of 30 minutes, when I compress it, compressed file is also of 30 minutes only. Only the size is reduced. So how size is reduced is, whichever are redundant information in that file, means unwanted information will be there in that file. No, those all unwanted information are removed. Unwanted information means some wrong data or some extra noise like that. So those all information are removed from that file and it is compressed. So this is how data compression is made. But remember, file data is not affected. Only the file size is affected by data compression. Understood? So whenever I compress my 30 MB 30-minute file, I can reduce it to 25 MB. Still that file is of 30 minutes only. Getting means data is not affected at any cost. Understood? So this is what data compression. So sometimes if you are sending video to your friend and that is of maximum size, then what you do is you cut that video into two halves and you send two different videos, right? But that is not data compression. That we consider as data trimming. Data trimming means data is reduced, not data size is reduced. Understood? So come to data compression then. Data compression means reducing the size of a file. So why we need data compression? Did you understand? Because sometimes maximum size file, if you want to send, then it takes more time. Clear? So if you compress it, then within short time you can send it and you can send it to many people. So that is data compression. So data compression is reducing the size of a file and information in data compression usually not represented efficiently. Because of compressed data, the information is not represented efficiently. Data compression algorithm represents information using few bits. Means large sized file may be consisting of some kilobytes, megabytes is reduced into few bits. So for example, the compression techniques we can use are zip, compress, GIF and fax. So you might have heard about zip. So if you are sending a lengthy file, sometimes you might have heard zip the file first, then send it. Such notification you might have seen. So zipping the file means what? It is nothing but compressing the file, means reducing the file size by removing some unwanted extra bits that are not of use, that are not of actual data. By removing those such data, we can compress the file. Understood? So whatever block oriented information we have seen, no? So those block oriented information can range from few bytes to several hundred kilobytes and occasionally several megabytes. So data compression utility consisting of compression with zip and other variations that exploit redundancies, means extra unwanted information, to import the original file that require fewer bits to transform and less disk storage space. So using data compression, we can reduce the size of file, so it will help us to use the less disk storage space. So now come to next topic, that is block oriented information. So for block oriented information, data compression can be done using two different types, that are lossless data compression and lossy data compression. So producing a compressed file from which original data can be recovered exactly is known as lossless data compression. Lossless data compression means what? Producing a compressed file from which the original data can be recovered exactly. Exactly means as it is in original file, is known as lossless data compression. And however, lossless data compression data are limited. They can achieve a limited compression rate. So for example, the technique used in lossless data compression is GIF, and that is graphical interchange format. So GIF is used mainly for simple images such as line drawing, images containing simple graphical shapes. So on screen you can see now these two images are GIF images. So you can see here these two are simple images. There we have some line drawings, some graphical shapes like circle, oval. Understood? So lossless data compression can be applied for GIF images, means those are very simple. And now come to lossy. Okay, sorry, before moving to lossy, did you understand lossless? So lossless means the name itself represents when we compress the data, there is no loss in data. As the original data is there, we get the same. Means when we uncompress the compressed file using the compressed file that is compressed using lossless data, we recover the original data only. Clear? Now come to lossy data compression. So this scheme, means lossy data compression scheme, produce a compressed file from which only an approximation to the original information can be recovered. Approximation to the original information can be recovered. Means what? Whenever we compress any file using lossy data compression technique, Later we can uncompress it. So when we uncompress it, we recover the approximate data from original, not same exact data as in original. We can recover approximate, means data may be like this, like that, approximation, okay, not original data. In lossy data compression, we use a technique called JPEG. JPEG means Joint Photographic Experts Group. So this experts group, that standard, provides a lossy data compression algorithm that can be adjusted to balance image quality that varies with different file sizes. So you can see on screen, these are the two different JPEG images. So first of all, let's compare between GIF images and JPEG. GIF images are simple images, but they are what? Exact images. In GIF images, we can see where is the end, where is the edge, where is the start, where is the end. Very clear boundary and clear picture we can see. Okay. In JPEG, compared to GIF, images are more quality, while they are more good. Clear? But we cannot see exact outline of image. Normal shape we cannot see. We can see approximately this flower may be like this, approximately this cat may be like this, but there is no exact information about the image. Understood? Okay, one more simple example I will give you for GIF and JPEG. So if I show you one cat and I tell you to draw the cat image. So whatever drawing you do, that is GIF, right? Means in that drawing, each part of cat, means each edge and each, that may be each finger, each part of the cat will be very clear, right? But in JPEG, what happen is, if I tell you to take the picture of cat, then you will get the photo of cat, right? So in that photo, can you get the exact image of cat? No. Photo will be approximately, cat will be like that. Understood? So this is what GIF and JPEG. Means what? In GIF, we get the lossless data compression. Means as the data original is there, in the same way we get. But we don't get quality there in GIF. Understood? In lossy data compression, in JPEG, we get good quality pictures, good quality images, but those are not exactly same as original. Those are approximately same as original. Understood the lossy and lossless? If you have any doubts, then later you can ask. Now move to the next topic, that is data compression ratio. So already we have seen data compression means what? Data compression means reducing the size of data, right? Data compression ratio means it is defined as the ratio of number of bits in the original file to the number of bits in the compressed file. For example, formula for compression ratio is compression ratio equal to number of bits in original file divided by number of bits in compressed file. So now consider one example to calculate the compression ratio. Consider a file storage size is 10 MB. Consider we have a one file and its size is 10 MB, and to reduce its size we have compressed it and it is compressed to 2 MB. Getting it is compressed to 2 MB, then it has a compression ratio that is 10 by 2. Why 10 by 2? Number of bits in original file. Original file means 10 MB divided by number of bits in compressed file. So compressed file size is 2 MB. That is why 10 by 2. So 10 by 2 equal to 5. So compression ratio of this particular file is 5. Understood? Okay, now come to next topic, that is delay. So in some application, whenever we transfer some blocks of information, we may get delay because of some intermediate interferences, means some intermediate corruptions. There may be delay in transmission of information from source to destination. Understood the delay means? So how we can calculate such delay is equal to T propagation plus L divided by R. T propagation equal to D divided by V. Here D means distance of destination from source. From source to destination, distance we represent as D. V means speed of light. T propagation means propagation time. Propagation time means time. Already we have studied propagation time in first unit. Propagation time means time required to propagate a message from source to destination. L means bits of information. L represents size of information. R means bit rate. So bit rate also I have told you in first unit. Bit rate means number of bits transmitted per second. So if the distance can be controlled for the placement of file server, the time to transmit the file can be reduced. The time to transmit the file can be reduced. Okay. Now bit rate means what? Number of bits transmitted per second. So if some file is there, that is, if we transfer it 10 bits per second, then it takes 10 minutes. If we transfer it 10 bits per second with bit rate 10 bits per second, then it takes 10 minutes. Consider I want to transfer a file in 5 minutes. I want to send that file in 5 minutes. Then what we have to do? We have to increase the bit rate. Clear? We have to increase the bit rate. So when we increase the bit rate, means when we speed the transfer, then automatically time is reduced. If we transmit 10 bits per second, then it takes 10 minutes. Clear? If we transmit 20 bits per second, then definitely it will take 5 minutes. Understood? So what? If you increase the bit rate, time is reduced. If you increase the bit rate, then time is reduced. If you decrease the bit rate, means if you decrease the speed of transfer, then time takes to transmit is increased. Means time and bit rate both are indirectly proportional to each other. So this is how delay in any transmission can be calculated. Now let us move to next concept, that is stream oriented information. So in block oriented information, the compression methods used are lossless data compression and lossy data compression. Like that, for stream oriented information, the compression methods used are noisy data compression and noiseless data compression. So noisy data compression means when the file is compressed, means when any video or audio is compressed, some unwanted noise is added to that because of compressing. Noiseless data compression means when any video or audio is compressed, no any noise is added to that video or that compressed video or audio. Noisy data compression gives more quality than noiseless, but noiseless data compression will give exact as original and noisy data compression will give approximate information. Now audio data compression. So to compress any audio, we use techniques such as pulse code modulation (PCM) and linear predictive coding, that is LPC. And for video data compression, we use techniques such as DCT and MC. DCT means discrete cosine transform. MC means motion compensation. So only the basic part is there about data compression for your syllabus. Not necessary to study these all techniques in detail. Only you remember name of techniques. For audio data compression, PCM and LPC. For video data compression, DCT and MC. Thank you.